Thank you very much, sir, for this wonderful presentation. We would like to hand over to Professor Onumaye, who is the chairman of this plenary session, so that he would, of course, handle the questions that may arise after. So we hand over to Professor Onumaye.
Chat so that they
please, host, may you unmute Professor Onumaye. I think he's using Dr. James Ajay account. I think his name is also there. So can you please unmute Professor Onumaye? He's the chairman of this plenary session.
He's already unmuted.
Okay. I think Professor Onumaye may be with. Okay. I think Dr. James is okay. Okay. So Professor Onumaye can please take over as the chairman of the plenary session.
Hello, I'm here. Hello, MC. And the speakers for the plenary session ready. I don't have the
it's because we're together, so
I get the list of their names. Do I know the speakers to call them?
I think it's this person that spoke.
Ibrahim, okay. I've listened to Ibrahim. Very wonderful presentation. We want to thank you for. current mathematical modeling related to medicine is a very important issue for discussion. I was expecting to hear about your effort in Ebola disease and the current COVID-19 issue. How can mathematical modeling help us with so much our older generations using direct vegetations, medicine, they were living so long and they did not have these modern medical facilities. I used to wonder, there were so many of them dealing directly with vegetation, taking herbs and knowing what to take to elongate their lives. How is modeling thriving in your studies in Ilorin as to COVID-19? Is there any going research in that direction? Or are we going to just keep quiet and wait for the rest of the world to provide the vaccination for us without making our own contribution in this land? These are areas I thought you may make a word or two there. Prof. Is Professor Ibrahim still on?
Can you hear me, sir?
No, I can't hear you. I said I've thrown my question to kickstart.
Yes, sir. Right now, some of myself and my PhD research team here in Ilorin, in fact, we didn't rest. The current, I want to even tell you the effort that we've done, published in a Scruple Q1 just of recent, not up to a week, that was recently released. I want to give you the title. On the computers, materials, and continuum. It's a Q1 journal. And it has to do with analysis and dynamics of fractional order mathematical model of COVID-19 in Nigeria using Atagana Balenois operator. Myself, Olumoyiwa Peter, Amjad, and a host of other people carried out the research, and it was published in a Q1 journal, Computers, Material, Continuum. So it's free. Anybody that wants to Google search that. Analysis and dynamics of fractional order mathematical model of COVID-19 in Nigeria using Atagana Balenois operator. It's a Q1 journal on COVID. And in there, in fact, we didn't stop. We still have, we look at a 6 compartmental model there. We still have about 10 submitted, but waiting right now. Some are on Ebola, some are on tuberculosis, and some are on this directly COVID-19. But in this one, published just of recent, less than about a week ago, under this computers and materials and continuum, is a Q1 thing. We look at 6 compartmental model: the XDT, the EDT, the IDT, the QDT, the CDT, and the RDT. So where does, like we normally represent those things, the susceptible for X, E, the undetected individuals who are infected or suspected case of COVID-19 that need to go through incubation period before this susceptible symptom can be noticeable. Then we have the Q there for the quarantine, those people that were just quarantined. Then we have the C class there that represent the confirmed case of COVID-19 from quarantine category. The R of T represent the recovery class. So then in one of the papers also submitted, we took into consideration what we've just made mention, some of the supplements. We didn't call them ABA or whatever, but we said food supplements due to what we call body immunity. Once a body is having this immunity, it will be difficult, because I remember ginger is a natural product. Ginger, garlic, clove, honey, turmeric. today, I still take as my morning tea. That is my major tea now for morning. And in the evening before I sleep also, I don't joke. Ginger is a natural fruit. So ginger, garlic, turmeric, honey. Once you add all these things, it will be able to give our body immunity. And tendency is there that there is also another journal that I read, not quite long, that is always good to do what they call steam bathing. You do this steam bathing and also you inhale some steam. So that's all about this COVID-19. Some are yet to be published. Some are undergoing review. Some are already published. On the terrorism, it's already published. On this COVID-19, using the data of Nigeria, as at the time we published the thing in the Journal of Computers, Materials, and Continua. So, to answer you, sir.
Thank you very much. Thank you. I think the floor is open now to anybody who wants to ask question from the speaker.
Yes.
MC?
Chairman, sir.
Yes.
Can I speak?
Yes, please go ahead. Introduce yourself.
All right. Professor Stephen Ona is my name.
Ah, okay, my director. Please go ahead.
All right. Let me just follow suit from what the chairman of this session has just said. In thanking the presenter for a well-written presentation. It is quite illustrative and informative. My observation and comment is in one particular area. And it happens to be in the aspect that I think there is need for more emphasis, and I don't know how we go about it, but I want to put it across. Now, I'm putting it to the presenter. In modeling, we know, like we have said in your presentation, that systems that we model sometimes are very complex for full mathematical representation to capture. And because of that, we normally identify those vital aspects of the system and the very important ones so that we represent them in our mathematical equations, be it ordinary differential equations, partial differential equations, systems of equations, etc. Now, in doing that, there is always an offshoot of existing mathematical formulations that we use in modeling our own chosen systems that we want to study. Now, one thing that I've observed over time in presentations by our young colleagues, and sometimes even in publications by young colleagues, is that when the mathematical formulations are done, little emphasis is placed on the mathematical analysis of those formulations. What I mean is that if a modification of an existing equation is done to suit our system that we are modeling, I expect that the existence theorems relating or related to the modified equations needs to be amply demonstrated. In addition to the regularity theorems and all of that, so that the amount of mathematics that is seen in modeling represents a good part of the work. But oftentimes, what we see is that many publications are bereft, if I'm permitted to use that word. Many publications are bereft of this in-depth mathematical analysis before we go into demonstrations, verifications, and all of that. So how do we, as senior colleagues of these young people, guide them to be sure that what they are doing has a good content of mathematics? That has been an issue that I want to put forward. How do we ensure that? Thank you very much.
Okay, it's a promise. Very soon I will invite you to come and examine one of my PhD students, Professor Onayela. You see, you will see what we do with my team here. We take care of the mathematical analysis. I understand your fear, so that you see so many people will move from this issue of susceptible, do the little assistance, positivity, and ends after reproductive number, which I, for one, have been challenging. You remember while I was in my study with you people, here in Ilorin, what I do with my team, you must, because most real life situations, you cannot solve them analytically. One, you have to use numerical method. And then in the course of our numerical solution, which I quite much agree, I've gone out to examine so many PhD also with so many of these senior colleagues. They will end up after reproductive number, but I don't want to mention names. But I do tell them that by the time you compare the PhD's material here in Nigeria with anybody even in Benin, Ghana, not to talk about even America, then you will discover the real mathematical analysis is omitted. Vis-a-vis, let me tell you 2 or 3 other things. I have my trademark. Anybody that comes to examine my students, first of all, you see the flow diagram of our new thing. We tell you most existing model and what is going to be the missing link. So from the missing link, you will see it vis-a-vis our flow diagram. And we itemize. Look at this I there, it's not in this. Look at this one there, it's not in this. Then what is each? What will be the contribution of each? After that, we move to the concept of global asymptotic stability, Lyapunov, optimal control, because you need to know at what material time are you going to have that optimal value. After that, we solve our epidemic model. We don't stop at only the mathematical biology and tell you that since R naught is this. No, we move. And I'm quite sure I've invited so many professors all over Nigeria, because I don't limit I pick from north, pick from south, pick from southeast, and what have you. So the essence is that we have what called cross-fertilization. I remember 4 or 5 years ago, Professor Onomaye challenged the same thing, that how come so many of our students, most of us that we say we keep on working in modeling, we know that the real life situation thing, you can't solve them analytically. How come people are running away from numerical method? And I keep on saying it's because it could be the advisor, the supervisor is also not that good in numerical solution. So not only numerical solution that I'm telling you now, we equally go one more step, cost effectiveness. If it is a vaccine that I'm talking about, we now look at it. What will be the cost effectiveness? Even if the vaccine happen to exist, It may happen in the next 5, 10, 20 years. So we look at that, which we call health economics. So we don't just stop at the reproductive number. Thank you for that observation. And I've been telling anywhere they happen to invite me, I've been telling my colleagues, please don't always stop at this R0 thing. Try to put some mathematical analysis and let everything be meaningful, because things are not just there for fun. Lyapunov have a role. Sensitivity analysis has a particular role. Optimal control has a role. Numerical solution. Vis-a-vis, are you looking at it from variational iterative method? Are you looking at it from DTM? I told you what we look at here is this man's operator, Atagana, and this thing that I just read out now. We look at a special operator by these two people, Atagana and Belenois. Atagana is based in South Africa. Belenois is in Turkey, but in Romania. So they were able to get a good operator, and the thing is able to work with what we so, and we use the operator, and it solved perfectly because it was a mathematical data collected from Nigeria and National Center for Disease Control, NCDC, in Abuja, as at the time we carried out this research, just about 5-6 months ago. So it was that data that we used in getting this result. But let me equally tell you also, yes, in the analysis that you keep on saying, so many of our people, which I quite much agree with you, it depends on the orientation of the supervisor and the supervisee. Most supervisee don't want to grow, because if they want to grow, they're supposed to equally research more than even their supervisor. The time that we bagged our own PhD, there wasn't much emphasis on the internet. Most of us have to travel to National Medical Center. But these days, just right inside your bedroom, the Android phone will provide you with latest information. In fact, more than millions of articles are written on mathematical modeling of COVID. And I can tell you less than 1% from Nigeria. I've seen somebody, a lecturer from BUK, published also in the Q1 journal that I published. I've seen some other people from the Southeast. I've seen one from South-South. I've seen one from Southwest. So this is a good development for different models, different approach. Thank you very much. Do we have any other?
Hello, good morning.
Yeah, good morning.
Good morning, sir.
Yeah, good morning, Professor Rashid.
Yeah, thank you so much for that beautiful presentation, sir. Mine is just in form of a comment. I supposed to have joined this session from 9 a.m., but the message forwarded to me by the President and Chairman in Council of Computer Professional Register Council of Nigeria, that's Professor Charles Wadia, who is supposed to be in the program, but despite his very busy schedule, he sent me as one of his council members to represent him in this event. And I want to also appreciate the management, and he sends his goodwill message that the association is doing fantastically well, and the pillar of computing is mathematics. So there won't be an innovative advancement in the area of computing without development in mathematics, particularly in the modeling and simulation. And of course, the knowledge-driven society cannot even flourish without deserve attention in the area of modeling and simulation, because that is when we are able to really study the environment, and based on what is happening in the environment, we are able to take some decision that will advance that particular environment. And that is the essence, the beauty of modeling and simulation. And my comment is just that TechFund is aggressive now, trying to see how relevant textbooks in all these areas will be developed, so that even at the university level and in other tertiary institutions, students will have access to relevant materials in all these important areas. And I think Professor Ibrahim, our mentor, has really done well in the area of modeling and simulation. I want to encourage that sensitizing even people from non-mathematical background is also very, very important, because we really need to study our environment to be able to devise strategies for advancement and also for sustainability in that environment. We are lacking in this part of the world when it comes to having knowledge of what is going to happen and the trend. And that is why we always adopt the principle of we'll cross the bridge when we get to it. And when you get to a stubborn bridge, then you will not consider the cost of getting to the point of the bridge and also the cost of even getting back. And that is why we have a kind of policy somersault. I think mathematicians are positioned to play a fundamental role in advancing a knowledge-driven policy for the country, so that we can also be at the par with the rest of the world. Once again, I want to thank the chairman and the organizer, and I bring the goodwill message of Professor Charles Onuwa Uwadia, the President and Chairman in Council of Computer Professional Register Council of Nigeria, to the whole house, and he sends his apology for not being able to make it, and I'm here to represent him. I want to thank you once again. Thank you.
Thank you. The last speaker. Are there other contributions? Are there other contributions? Or we draw this to a close, MC?
Okay, so if there is no other contribution, I think we'll just bring it to a close.
Yes.
Thank you very much, sir.
Okay.
Your help and coordination of this plenary session. Thank you very much, Prof. O. Ibrahim, for this wonderful talk and motivation also for we young ones. Thank you, Professor Stephen Ona, for also your contribution, sir. We are very grateful. We thank you all for joining this plenary session and opening ceremony. We would now be going to our two parallel sessions. There are two parallel sessions, one for applicable mathematics and the other one for applied mathematics. The details have been posted on the chat box. We really enjoin all the participants to join their respective parallel sessions to give a presentation of their work. We are supposed to start by 12, so we would start right away and break into these different parallel sessions. Thank you very much. Thank you all.
Thank you. And thank you very much. And I want to thank every other person too for a successful opening ceremony. Thank you all.
How is it going to applicable and applied? Instead of peer and applied, applicable and applied mathematics. What is it? So let me what the applicable is applied now. You have finished your whole part.
I've finished my part. I will just wait for while they are doing this.
Question will be,
I love it.
Applied.
Applied, yes.
Okay, I will log applicable. Optimization is there. I think optimization is to be there.
Okay, I think the screen is showing the for parallel questions. Okay, that's applicable.
Okay.
Then apply this.
Okay, those are the next branches of mathematics.
Yeah.
And then applied mathematics.
Optimization, statistics, model. We send information to WhatsApp. Applicable. Thank you very much.
Talking of differential equations.
Thank you, Sir Professor Ona.